Guys, if you're watching this, that means I'm doing jury duty. So I want you to be, please be so awesome for the sub. I know you will be. Let's have an awesome report. And this is all going to be worked out of last night's homework, which is page 154 and 155. I'll work out all the problems. Please double check yours. If you didn't do it, maybe you should try a little bit and then watch a little bit of the video and see how the problems go. I'll do them all sequentially. Pause it where you need to. If you don't get done with the video, please feel free to watch it at home and figure it out. Okay, so page 154 and 155, or 154 and 155 were last night's homework from Monday. So remember, we're dealing with inequalities, so we're talking about shading a region. So I'm going to try and keep the vocabulary all the same. Okay, so again, please be awesome for the sub. Awesome. I don't want to have a bad report when I come back. I'm doing the civic duty that our great nation has us do from time to time, and if I do get selected for a jury, you will watch the rest of whenever I would get back on video using the Chromebooks. Also, when you're done with the Chromebook, please, when you put it back, please plug it in. Don't just act like someone else is going to do it for you. Please be responsible for your computer. That's the only fair thing to do. So please take care of that for yourself. Again, remember this week there's not going to be any tests or quizzes. If you do need to make up last week's quiz, the one that was on Tuesday last week, it is in the testing center. The testing center is open Tuesday and Thursday this week in the Math Science Resource Room. Sometimes it might get too busy. You might have to come back. You might have to come back because there's not enough room for you. That's how the Resource Center works. That's why a lot of times I don't do that. So I would strongly encourage you to get over there if you do need to make it up. There's probably about 15 of you that need to complete that quiz. You were absent, okay? Please be responsible. Get over there. I understand. It might be busy. Figure out other times, whatever off periods you have to get over there to make up what you need to make up as far as that goes. You're allowed to use a calculator. They will not provide one for you, so make sure you walk in with one. Okay, so when you walk to the back of the Math Science Resource Room, just go all the way back and just let them know, hey, I'm here to take a test from Mr. Stirrup. They will pull it out for you. They will give it to you. And, don't think you're going to take 10 minutes and it'll be done. If you walk in towards the end of the period, they're not going to let you take it. So get in there, get it done, and then you submit it back to her, and everything will be taken care of. So I hope you guys do great. Again, please be awesome for the sub. All right, so problem number one we're going to take a look at. Let's take a look. Problem number one, we have y is less than 1/2 x minus 3, and we also have 2x plus 4y is greater than or equal to 4. Okay, so remember, when we're working this, we're looking at solid and dotted. This one, the red will be dotted. The reason it's dotted is this sign right here doesn't have the equal sign. So this has a y-intercept of -3, so down here at -3. And from there, I'm going to go up 1, right 2, and you create your dotted line. Remember, 0, 0 is going to be normally a good test point for you unless the line goes right through it, then you have to pick something else. The second problem, it appears that we are going to have a solid line because we have the equal sign there, okay? Make sure you understand that concept. The cover method will work. Remember, the cover method allows us to find where it crosses the x and the y axis. So if we cover up, we say 2x equals 4. So 2 times x equals 4. So x equals 2. So x equals 2, you go right here, put a dot on 2, and then you cover up this one. So I have 4y equals 4. So 4 times what number gives me 4? And that would be 1. So in the y direction, I'm going to put this. Remember, we said it was solid, so we're going to do our line just like this. At this point, it appears that 0, 0 is going to be a pretty good test point for us. 0, 0 is below the blue and above the red. Agreed? Okay, so that's the test point. You're looking for where it's true and true. So you're going to take 0, 0, and you plug it in. You plug it into your x and y. So on this first one, I have 0 is less than 1/2 times 0 is 0 minus 3. Is 0 less than or equal to -3? No, that gives us a false statement. Okay, so that we were dealing with the red, so that means we're going to shade on the bottom side of the red. So it could be here in this region here or in this region here. So there's two different things. So we have to decipher what it's going to be for the blue. So on the blue, again, we're going to take 0, 0, plug it in for our x. So 2 times 0 is 0, plus 4 times 0 is 0, is greater than or equal to 4. Is 0 greater than or equal to 4? Again, that's also false. So we created 2 false statements on this. Okay, so think about this. I got a false on the blue, so I'm not going to, because 0, 0 is underneath the blue, I need a shade above the blue. Being that 0, 0 is above the red, I need a shade below the red. So the only region that's above the blue and below the red is this region right here. Okay, this has an infinite amount of points. Yes, it spans out forever and ever. Okay, problem number 2. Okay, that says problem number 2. We have y is greater than 1/2 x minus 1, and we have y is greater than or equal to negative 2x plus 3. Again, when we take a look at it, we have to decipher if it's solid or dotted. So our top equation we'll do in green. It is dotted. The reason it's dotted is because that doesn't have the equal part. Okay, this is in slope-intercept form, so I'm going to plot negative 1 first. And then I'm going to go up 1 right 2. And again, we said it was dotted. Our second equation, we'll go ahead and do in blue. This is going to be solid because I have the equal sign there. I have a y-intercept of positive 3. I'm going to go down 2 and right 1. And it was a solid line. It appears that 0, 0 is another really good test point. So 0, 0 is right there. Okay, we're going to test it. If that's above the green and kind of to the bottom left of the blue. So we're looking for true, true. If we get false, false, I need something else. But we can answer our questions. All right, so we'll take 0, 0 and plug it in. So I'll plug 0, 0 in here and here. So if I take this first one, I'm going to get 0 is greater than 1/2 times 0 is 0 minus 1. Is 0 greater than negative 1? Sure it is. It's one number to the right. Okay, so that gives me true. And let's see if we get a true, true on this one. So I plug 0, 0 in. So plug 0 in for y. It's greater than or equal to negative 2 times 0 is 0 plus 3. Is 0 greater than or equal to 3? No, that gives us a false for that one. Okay, so we get true and false. So now let's think about this. The green is, above the green is true, but on this side of the blue is false. So this side of the blue is all going to be true. So I need to be above the green, up here, and to the side of blue. So here's our shaded region. If I picked any points up here would give me a true, true statement. Problem number 3. We have y is less than or equal to 1/2 x plus 2, and y is greater than negative 1/4 x minus 2. All right, so let's take a look at it. We'll do the top one in green. It's going to be solid because we have the equal sign. We have a y-intercept of positive 2, so we put a dot here. My slope is 1/2, so I'm going to go up 1, right 2. And again, it's a solid line. Okay, 0, 0 is a good test point because the green doesn't go right through it. All right, so let's take a look at the other one. We'll do it purple. This is going to be dotted, okay, because it doesn't have the equal sign. So I have a y-intercept of negative 2, and the slope is negative 1/4. So I'm going to go down 1 and right 4 from that. So down 1, right 4. And we said it was dotted, right? Okay, so again, 0, 0 is a really good test point for us. So let's see if that's going to work. So I'll plug 0, 0 in the top. Remember, it goes into the x and the y. So I'm going to get 0 is less than or equal to 1/2 times 0 is 0 plus 2. Is 0 less than or equal to 2? Yeah, that's true. So that gave me a true already over there. Cool, we're halfway there. And then let's take it on this one, same idea. I'm going to plug 0, 0 in. So I get 0 is greater than negative 1/4 times 0 is 0 minus 2. Is 0 greater than negative 2? Hey, that's also true. So this is my true, true region. So the true, true region, we found it. So we just need to shade this region here. And any one of those points in this shaded region is our answer. All right, problem number 4. I have y is greater than or equal to negative 2x plus 3. And then I have y is less than x plus 1. Okay, so again, this is going to be solid, right? Because it has the equal sign. I have a y-intercept of positive 3 and a slope of negative 2. So from that point, I'm going to go down 2, right 1. Down 2, right 1. Solid line. 0, 0 is definitely over on this side of it. Okay? All right, so our other line, let's do it red. This will be dotted because I don't have the equal sign. So I have positive 1. And from that, I'm going to go up 1, right 1. And we have dotted. So 0, 0 is down here in this little region down at the bottom. So 0, 0 is my test point. So let's take a look at where we get the true statement. So again, I'm plugging in for my x and y. So in this top one, I'm going to get 0 is greater than or equal to negative 2 times 0. That's 0 plus 3. Is 0 greater than or equal to 3? That's going to be false. Okay, so that means I would have to shade the other side of the blue. Okay, let's see if the red, what happens with the red equation. Again, plug in 0, 0 in. 0 is less than 0 plus 1. Is 0 less than 1? Yeah, that's true. Okay, so let's talk about this. The blue line, I have to shade the other side of it. The red line, I still have to shade the downside. So on the red, I'm shading down here. On the blue, I'm shading over here. So the only region that works is this region right here is our feasible region. Okay, so again, we're shading the appropriate side because we wanted all of that down here for the red, but this was the only region that worked on the right side of the blue. Problem 5. Okay, first equation, dotted, because we don't have the equal sign. This one is set up in standard form, so we can use the cover method. Okay, so if I cover this up, I get 3 times x equals 6, so 3 times 2 equals 6. So x is equal to 2, so on the x-axis you put a 2. And then here I have negative 2y is equals 6. So negative 2 times negative 3 gives me 6. So on the y direction, I'm going to put a negative 3. And then I have a dotted line. Okay, so 0, 0 is up in this region still, correct? Now let's go down here, we'll do it in purple. Slope-intercepts, I have a y-intercept of negative 1. And a slope of up 1, right 1. Up 1, right 1. Oh, that's a solid line, right? Solid, sorry, I didn't say that before. Solid because we did not have that. So 0, 0 sits above both of them. So I have 0, 0, that's my test point. Okay, so see if that works. So 3 times 0 is 0, minus 2 times 0 is 0. Is that greater than 6? Is 0 greater than 6? No, that's false. That's false there. So that means I want to shade the other side of the green. So it's down here that I'm worried about. Here, this whole region here. But I need to figure out which other one. Let's see what happens with the purple. Okay, so I get 0 is less than or equal to 0 minus 1. So 0 is less than or equal to negative 1. Hey, that's also false. So this region here created a false and a false. So that means I'm not going to shade above the green. I'm going to shade below it. I'm not going to shade above the purple. I'm going to shade below it. And the only region that works for that is right here. This whole region right down here. So if I picked any of these points down here, these would give me a true statement below. Problem 6. Just about done with the first page. Problem number 6, we get 2x plus 3y is greater than 6, and then I also get negative x minus 3y is less than or equal to 2. Both of these are set up, we can do the cover method. Yes, we're going to get a fraction on one of them, but that should be okay. We'll do this first one in red. It is dotted because I don't have an equal sign. So if I cover up here, 2 times what number gives me 6? 3. So x has to equal 3. And then 3 times y equals 6. So 3 times 2 equals y. So I'm going to do y in this direction. Again, we said this was dotted. 0, 0 is down underneath there. So see what happens there. And then we'll do this one in, I don't know, black. Would be all right. All right, if I do the cover method here, I get negative x equals 2. So x equals negative 2. So on the x direction, I'm going to plot a point right here. And then if I plot this, negative 3 times y, negative 3 times y equals 2. So y equals negative 2/3. So in the y direction, I'm like down here. Okay, again, this one was solid, right? Because it was the equal sign. So these intersect out here. So hopefully this is region out here is not what we're going to shade. But 0, 0 is above the black. So 0, 0 is above the black and below the red. So see if it's going to work. So plug into the first one. I get 2 times 0 plus 3 times 0 is greater than 6. Is 0 greater than 6? No, that's false. So that means I need to shade on the other side of the red. So I'm not going to shade up here then, because that would give me the true. And then on the blue line, again, plug 0, 0 in. So I get negative 0, which is 0, minus 3 times 0, which is minus 3, or minus 0, excuse me, is less than 2. Is 0 less than or equal to 2? That is true. Okay, so let's think about this. I need to shade the top part of the red and stay on the top part of the black, because this already existed on the top part of the black. Well, that's going to be this whole region here. And that's done with the first page. So if you have questions about it, you might want to ask your neighbor at this point if they're about the same location as you. Okay? All right, problem number 7 and 8, they give you the linear equations. Let's see. Write the system of inequalities that match the graph. Okay, so it appears one of the lines crosses at negative 3. There's a negative 1, negative 2, negative 1, 2. That's negative 3 right there. Even though this stuff's shifted a little bit, but if you count down, it works. And then that goes up 1, 2, right 1. Up 2, right 1. That's a solid line. Okay? And the other one, other equation, we'll do in green. It appears that it crosses the y-axis at negative 5. So negative 1, 2, 3, 4, 5. And we have a slope of down 1, right 1. And that's also a solid line. And then it appears that they have this region over here shaded. Okay? So in the purple, a few things in the purple. I know my y-intercept by looking at it is negative 3. So that's the point 0, negative 3, but we'll just list it as b. And our slope, we just counted up. We counted up 1, right 2. So that's what we have. So if I use y equals mx plus b, I'm going to get that equation is y equals 1/2 x minus 3. Now we have to figure out our inequality sign here in a second, so we'll come back to that. So I'm going to go y 1/2 x minus 3. So we have to figure out if that is greater than or less than. We know how to have the equal in there because it's solid. Let's do the green line same way. So the green line we found by inspection, our y-intercept, our b value is negative 5. So that is indeed the point 0, negative 5. And then we have a slope of down 1, right 1. So negative 1 over 1, or just negative 1. So this has an equation, again, using y equals mx plus b. Plug in what we just found. We know we have a slope of negative 1, and then the x comes along, plus b, so it's negative 5, so plus negative 5. So again, we need to figure out y box. We know it's going to be equal because it's solid, negative 1x minus 5. Okay, so let's think about this. If I chose my point 0, 0, this is a tougher problem, but think about it. If I chose that point 0, 0 for my purple, okay, for my purple, in order for that to work, I need to figure out. So if I plug 0, 0 in here, I get 0, blank, negative 3. Is 0 greater than negative 3 or less than negative 3? And it's greater, so it should go this way. So this is our first equation. Let's do the same exact thing with the green, okay? So 0, 0 is up here, so I want to make it true. So 0 is, that would become a 0 if I plug 0 in there and there. So is 0 greater than negative 5 or less than? It happens to be greater. So these are my two inequalities that set up this system of equations. Number 8 is going to be done similar. Number 8, we have a dotted line. It appears it crosses one of them at negative 1. My negative 1's there. And so I know that my b value is negative 1, so that's the point 0, negative 1. And then I have a slope of that of going up to right 1. Negative, so up to right 1. So again, this one was dotted. And then my other line, make it blue, looks like it crosses at negative 3. Oh, cool. So my b value is negative 3 here, which is the point 0, negative 3. And I'm just getting that from my information on my graph. And it appears that I go up 1, right 2. So I have a slope of 1 over 2. Okay? I can go ahead and start making my equation. Again, I'm going to use y equals mx plus b. I'm not going to use the equal sign at this point, so I'm going to go y blank. My slope is 2x, and my y-intercept is -1, so plus -1 or just -1. Okay? Oh, I forgot to plot this point. I'm going to put this line up 1, right 2. This one's solid. And it appears this is the region we've got shaded down here. Okay? All right. So this is my first equation. We'll figure that out in a moment. My second equation, we're going to do, we have y using mx plus b, y equals 1/2 x plus -3. So that'll be y. I'm going to have a box there blank, 1/2 x minus 3. So now we have to figure out what our inequality is going to be. Okay, so I'm going to use 0, 0, which is right here. And I need that to be true. So on my first dotted equation, okay, my first dotted equation, I need it to be true. So if I plug 0, it's 0, and that's 2 times 0 is 0. Is 0 greater than 1 or less than 1? It happens to be greater than 1, okay? We don't have the equal sign because it's dotted, so that's my first equation. It's all set. My second equation, I need, because I was above the red, I need now below, so this needs to be a false statement. Okay, so 0, 0. If I plug 0, 0 in, oh, there was an X right there, excuse me. 0 blank, that's 0 minus 3. Is 0 greater than -3? Remember, we want it false, so 0 is greater than -3, so I need to change it this way. 0 is less than -3 in that case, and that gives us that equation. Those are a little tougher ones, okay? The last few problems, I just have to scroll ahead because they're just solving. These are equalities. This is what we had been working on. Okay, so this might be a nice review for you if you had trouble with it. And then I had this equation as well. So we want to solve. We want to solve. Remember, when we solve, we're looking for where they share the points. So it looks like I could substitute in this right here to this part right here. So I'm going to bring this equation down. I have 3x minus 6 equals -18. This had been a y, but we know on the second equation that y equals this. So I'm going to plug 1/2 x plus 3 in. Let's distribute -6 to both. -6, half of -6 is -3. -6 times +3 is -18. And look what happens. These cancel each other out. So I get -18 equals -18. Is that true? Sure is. If that's true, that means we have infinite solutions. That means these are the exact same lines. They lie right on top of each other. Again, this was from the last unit. Problem number 10. We have 2y plus 4x equals -2. 2x plus y is equal to 5. These aren't really set up for substitution. They're kind of set up for elimination. We might want to flip-flop the order of this a little bit. So make it y plus 2x equals 5. I just flip-flop my x and y. Okay, so now we're going to take this equation here and this equation here, and let's figure out what we want to get rid of. We have to choose either x or y. I'm going to choose, let's get rid of y. So I'm going to take this whole equation here and multiply everything by -2. So that means that -2 comes here, and it comes here. So that's -2y minus 4x equals -10. I'm going to take this equation here and this equation here and add them together. So I get 2y minus 2y, well that's nothing. 4x minus 4x, that's also nothing, is equal to -2 plus -10 is -12. Is 0 equal to -12? No, that's false. So there is no solution here. That would have meant these lines would have been parallel to each other. Again, this is the last unit, so we're just reviewing a little bit. Number 11, we have y plus 4x equals -7. I have 2x plus y is equal to 0. It looks like I could do elimination on these if I wanted to. I don't have to do too much. Maybe if I just multiply this whole one by negative 1, so I'm going to get negative 2x minus y equals negative 1 times 0 is 0. And then I'm going to combine this equation here and this equation here together. I'm going to add like terms. Remember, same value. So y minus y cancels out. Good. 4x added to negative 2x is going to be positive 2x. Negative 7 added to 0 is negative 7. So this is going to show me that I get x equals negative 7 over 2. That's my x component. We have a solution. Okay? That's the x component of my solution. Now I want to find my y component of my solution. Okay? So I'm going to take negative 7 over 2, which is an x value, and I'm going to plug it in either place. So I'm going to plug it in right here. Okay? So I get negative 2x minus y equals 0. So negative 2 times negative 7 over 2 minus y equals 0. That's going to give me 14 over 2. 14 over 2 is 7 minus y equals 0. Negative y equals negative 7, because I have to subtract 7. So y has to be equal to 7. So my answer, my solution to this problem is negative 7 halves, comma 7. Problem number 12. Problem number 12, I have 4x minus y is equal to negative 4. And then I get negative x minus y equals negative 2. So these are kind of set up to do elimination. It looks like if I multiply one of the equations by a negative 1, okay, that's a negative 1. So that's going to give me x plus y equals 2. And then I add my original here that I didn't manipulate and the one I manipulated. If I add those together, what value falls out? I think the y does. Okay, so I get 4x plus x is 5x. The y's cancel out, and I get negative 4 added to 2. Okay, and that's positive 2, so that becomes negative 2. So my x component becomes negative 2 over 5. Okay, so we do have a solution. So that's my x value. And then I'm going to take my x value, and I'm going to plug it into either of my two equations. Doesn't matter which one. I might plug it in right in here, to this equation. That was one of my originals. So I get negative x, so I get negative x, so that's going to give me positive 2 over 5 because negative, negative, minus y equals negative 2. Do you remember the trick to clear the denominator? I'm going to multiply all three terms by 5. So I get 2 here, minus 5y equals negative 10. Okay, so again, what I did is I multiplied this by 5 over 1, this by 5, this by 5, and that's how everything got cleared out. I'm going to subtract 2 from both sides, so this is going to now be negative 12, and then I'm going to divide by negative 5. So I get negative 12 over negative 5, which is positive 12 over 5, and there's my y component. So, problem number 13, it says the inequality 3x plus 2y is greater than or equal to 93. So this is problem 13. Okay. They represents the number of x of multiple choice questions and number of y matching questions you could answer correctly to receive an A on the test. You have 20 multiple choice questions and 18 matching questions. You answer 20 multiple choice questions and 18 questions correct. Other questions right. Do you receive an F? Or do you receive an A? So you need to score higher than a 93. So I'm going to take, remember, we just said that X is the multiple choice. So it says you got 20 multiple choice. So 3 times 20 plus 2. And then what was y? Y was the other type, and y was 18. And if this happens to be greater than or equal to 93, we get an A. So 3 times 20 is 60. 2 times 18, that is 36. Is that greater than or equal to 93? I don't know. If I add those together, I get 96. Is 96 greater than or equal to 93? Yes, it is. Do you get an A? Yes, you do. And that's what you're up to, okay? So, ladies and gentlemen, for tonight, so again, I don't know what days I'll have jury duty. I might be back on Wednesday. I might not. So you might have to be watching these videos for a while. So please make sure you are totally allowed on Schoology. Send me a message. If you have a message from today, send it early, before 5 o'clock, and I will answer that question on the following night's video so you can have your questions answered, okay? But your homework for tonight is going to be the page 156. It's only one side, so you have the remainder of the period to work on that. And again, all of you are expected to watch these, go through these. Please make sure your Chromebooks are back and they're plugged in. Log off, plug them back in the computer card. Okay, it's going to be a big help for us. So hope you all have a great day, and I look forward to seeing you next time I'm back at school. So have a great one. And again, please, please, please be awesome for the sub. Okay? Love you guys. Bye-bye.